Hello students. So as we have discussed about the different thermal spray techniques in our last class, so we will now in this lecture we will discuss about the different materials which can be deposited in thermal spray and their different applications. So first we will start with the periodic table. Just a glimpse of the periodic table. So it's something like this. We'll write the periodic table in the first row. We have helium, lithium, sodium, potassium, radium, cesium, and per what is called. Then we have beryllium, magnesium, calcium, strontium, barium, and Ra. And then the transition will start like cesium, yttrium, lanthanum, introduce and actinium materials. Then we have titanium, zirconium, hafnium. Then we have vanadium, niobium, tantalum. Then we have chromium, magnesium, and tungsten. Then continuing, we have manganese, Tc, and E. Then we have rhodium and titanium. Then we have cobalt. So this is Rm and this is Rh. Zirconium. Then we have nickel, radium, platinum. Then we have copper, silver, gold, and then we have zinc, cadmium, and mercury. And after that, we have group 3 elements like boron, aluminum, gallium, indium, thallium. Then we have copper, silicon. This is the metal like germanium, samarium, and lead. Then we have nitrogen, phosphorus, arsenic, strontium, tin, and bismuth. Then we have oxygen, sulfur, cerium, tellurium. Then we have fluorine, chlorine, bromine, iodine, and then at last we have helium, neon, argon, the rare, the inert gas, plutonium, and so on. So out of which there are some metals, for example, we talk about this tungsten, then we talk about tantalum, Ta, Ta. Here is Ta. this one. Then molybdenum, Mo. Should be molybdenum, not MgS with this one, this Mo. And titanium. These metals, they are these metals, they are basically the refractory metals or high temperature metals. And so tungsten, for example, is a refractory metal, high temperature application. Tantalum is again used in corrosion. Molybdenum is used in bond coat, and again titanium is used in corrosion. Then we have some alloys called MCrAly, where M can be nickel, chromium, or iron. These alloys are used for oxidation and sulfidation resistance. And also there is a nickel and graphite alloy which also serves the same purpose. Now there are few materials which can be deposited through cold spray, as we have discussed in our previous lecture. So cold spray is basically used to deposit hard and wear resistant coatings. And materials which can be deposited through cold spray as CRC and chromium, then tungsten carbide, tungsten carbide, cobalt. Then you can have tungsten carbide, copper, or you can have copper and diamond. Or you can have copper and SiC. You can see that it's basically a combination of a metal and a ceramic. So here you can see in this case there is a nickel is the metal, there is a chromium is the metal. In this case this is the ceramic, this is the metal cobalt. In this case copper is a metal. Here again copper, here again copper. So as we have discussed in our previous class, the metal part is actually the part which is getting plastically deformed and helpful in and is causing the adherence of the coating with the substrate. So you need to have a metal part when you are depositing coatings cold spray. And their applications of these cold spray coatings are in automobiles, in aircrafts, and in repair of turbine parts. And as we have said, there is no oxidation or crack involved in this cold spray, or even if there is some oxide, it gets removed through the shock wave generated. Cold spray are also used cold spray coatings are also used for safe electrical connections. And therefore, when lesser applications like lithium ion multi-cell batteries. It eliminates solidification stress. It enables thicker coatings compared to other thermal spray techniques. The defects are lower. Lower heat input, since we are using a low temperature to work piece, so there is no cooling required in the process. There is no cooling system required, unlike other cases. And there is a thing called a grid blast, which is mainly done to make the adherence better. Grid blasting is a way of projecting hard materials onto the substrate to cause sufficient roughness on the substrate, so that whenever the coating is coming, it gets deposited or the adherence is good. And since in cold spray technique already we are using a supersonic jet, so that takes care of this adhesion part, and there is no need for any grid blasting for pre-treatment of the substrate. And there is no fuel also. It's only because of the high velocity of the jet that is only involved, no fuel involved. And there is no need for masking, since the cold space is very much local, very much projected to a certain point, so there is no deviation from the line of sight. So no masking of the other parts is required, where we don't want the coating. And apart from that, it is also used in electromagnetic interference shielding, mainly used for security purpose. See, my shielding is done, and for that we require a non-porous conducting metal coating. Which can be done with the help of the CS technique. And these material basically would prefer to have copper and tin outside of the shield, and aluminum and zinc inside of the shield. It's used for military use, as told earlier. So this specific composition of copper and tin at the outside and aluminum or zinc at the inside can be very well taken care with the help of the cold spray techniques. Now there are other materials which are deposited with the help of cold spray or other thermal spray techniques, like can have carbides. Like carbides, you can have B4C carbide, which is used for neutron absorption. You can have Cr2C3, which will be a cermet metal composite. You can have hafnium carbide, which is for wear resistance. And can again have WCCO. These are basically with the help of, this is mainly can be deposited with the help of cold spray. And then we can have titanium carbide, can have zirconium carbide. Basically they are for hard and wear resistant coatings. Other ceramics, you can have aluminum nitride. It is used for high thermal conductivity. High thermal conductivity, and also it is a hard material. Then you can have a boron nitride, zirconium nitride. They are also very hard coatings for metallurgical protective coatings. Titanium nitride, apart from hard, it is also low friction. Coefficient of friction is very less here. Then we can have hydroxyapatite, HAP coatings also. It's basically a combination of calcium and phosphorus. This is for biocompatible coatings. Mainly used in medical implants. Then we can have calcium chloride, which is a solid lubricant. Also deposit oxides. Help of thermal spray. I can have Al2O3 alumina, is used in electrical insulation. And wear resistant seal. And have a composite of Al2O3 and TiO2. This composite is for erosion protection, wear resistance, and threaded guides. And have BaTiO3 is a piezoelectric material used in capacitor and piezoelectric devices. Then we have selenium oxide CO2 used in catalytic coating. Then we have Fe2O3, nickel oxide, and zinc oxide. These are applications in these are basically ferrites, application in ferrites, and waveguides, which have got application in waveguides, optical uses.